Let's just give us a test. Can you hear me? To back.
And now? Also? Okay, I prefer not to use the mic, is that better? Okay, some people do complain I shout a lot, so it should be fine. Just so there's no echo. Okay, good evening. So what does growing one of the hottest chili plants in the world have to do with the Google Cloud Platform? Chili plants need a lot of sunshine and regular water. And being in IT and always busy, I set out to see how I can use the Google Cloud Platform to monitor my chili plants. Hi, my name is Dries. You can get hold of me on my Twitter handle, Dries139. I design deep learning systems, and a vital part of the deep learning system is to get the big data and the connected cloud integration in place. Sorry, my notes is just... Can I please just restart? My notes is all going over on the other screen. And they did ask me to spend a bit of time. Okay, let's just release. Now I get my notes on this, right? That should work. Yes, there you go. Okay. Okay, so yeah, I left it that, and a vital part of deep learning systems is to get the big data and cloud integration into place. We shouldn't get too caught up in the hype and all the buzzwords around IoT and big data. If your data is hard to manage, that's your big data. If you connect devices to the internet or to your intranet, that is your IoT. It might not be someone else's IoT, it might not be someone else's big data, it's your big data, and that's all that matters. And there's ways to make it work for your scenario. In 2006, there were 2 billion connected devices. It's predicted that by 2025, there will be 75 billion connected devices. I think that's a bit conservative. I've read a few predictions around 200 billion connected devices by 2025. Do you see the problem? We're in a data explosion, and this is only the beginning. Everything Google has done seems to have been a series of well thought out events to get them to this point, to be ready for the data explosion. And I mean, after all, they've helped create this problem. Trying to index the internet and things like that. For the project, I used the Arduino-based Particle Photon microcontroller. It's powerful, it has an awesome maker community, and it's dead simple to connect to the cloud. From the representation on the right hand side, you can see you've got 8 digital pins on the right hand side, but we're more interested in the 6 analog pins on the left hand side. To measure the level of moisture in my chili plants, I'm using a very cheap soil sensor kit from one of the local electronic shops. How does it work? Water is a conductor of electricity, and by measuring the resistance between the probes, you can calculate the level of moisture in the soil. Here's a time lapse of me building the project. It's the best I could do. I couldn't bring everything here.
Terrible.
I wish it only took 30 seconds. Okay, there you go. And a quick disclaimer, no plants were harmed in the making of this clip. And using one of my wife's Tupperware for waterproofing, hoping that the Wi-Fi will reach outside. It did kind of. The particle photon comes with a great ecosystem. Most IoT initiatives fail because they fail to take in consideration the complexity of setting up a supporting structure around IoT. The particle ecosystem takes care of most of that for you. Here's 3 things that come with the infrastructure. It's the particle cloud, web IDE, and over Wi-Fi firmware updates. That's quite important. The web-based IDE, out of the box, you log into your favorite browser. I haven't tested it with Internet Explorer, but the other ones work. You've got a console at the bottom that takes you to a snapshot of your particle cloud. There's a tab to manage your devices. There's thousands of community-supported libraries. So if somebody brings out a new sensor, the supporting libraries will be managed by the community, and it's available in that libraries tab. To manage your code and structure your code, there's a codes tab. And then importantly for your actual project is to save, verify. We'll all know it as to compile your code. And then the last one is to actually flash your particle microcontroller with the firmware that you've just developed. The particle cloud is the messaging queue for the particle ecosystem. It's highly available and it's easy to use. Let's look at some code. So there's always 2 methods developing for the particle cloud. There's a setup where you initialize everything, and then there's a loop that just continuously gets iterated. We'll specify the pin we want to use, so we'll use analog 4. There's a helper method to read from that pin. We'll use a quick formula to convert that into a percentage, a moisture level percentage. I thought I was typing at full speed. It didn't feel this slow. And then all that's left to do is we actually publish that value to the particle cloud. Then you specify using an enum, you specify whether it's private or public, and you give it a name. So in this case, we'll use sensor, moisture sensor, sensor moisture. And it's a string. So in the back end, that's a JSON object that gets developed or gets created and sent to the particle cloud. Okay, here's a snapshot of the particle cloud. It's basically at that moment all the messages coming through the particle cloud related to your devices, all your devices, or specific to one or 2 of your devices. You'll get messages when your device comes online. It gets dropped, there's errors, and then also the messages you published to the particle cloud. In this case, we published the value for 92 read directly from the sensor. The second part of the particle ecosystem is to actually be able to communicate with the rest of the world. So now you've got your messages in the particle cloud, but it's not very useful there. And the particle cloud uses webhooks to expose the data to the outside world for consumption. A webhook is an HTTP callback to any of the events happening on your particle cloud. Okay, so I might have used a bit of a clickbait title claiming that Google loves your sensor data. Just how much do you think Google loves your sensor data? Any guess? A lot. Okay, as it turns out, a lot. They have teamed up with the guys from Particle, And by using webhooks, they've created an integration with the Google Cloud Platform. So if we look, so our end goal is to get our sensor data into BigQuery, where we can do our analytics, and we've got the full-scale data warehousing capabilities of BigQuery. But we send data to the Particle Cloud. So our first step is not to set up the integration, but to actually get to create an entry point into the Google Cloud Platform. And for that we'll use PubSub. PubSub is a messaging service. It's highly available, and it creates a communication channel between all the different independent services and apps available to Google. And you can actually use it for anything that comes in from the outside as well. So we create PubSub we start off by creating a topic. So you publish and you subscribe, and you use that by using a topic. So anybody that subscribes to that topic can consume data from that specific channel. The second important part is to create a trust relationship with the Particle Cloud by adding users and roles. Okay, so there we create a user, and we'll give the user a publisher role, since the data comes into the cloud platform, and we add the user. That is as simple as it is to create a PubSub topic. Now we're ready to create the integration. As you might have missed it, but there was a Google Cloud Platform little logo. That's the predefined template for the integration, and we give the integration a name. And all we want to know is, where does the data come from? So we've created we published to moisture sensor, and we want to know where it's going. And we've just created a PubSub topic, and we'll specify that topic. Remember to always use the fully qualified names. And in this case, I'll use my device called Dries. But you could also use an integration to any device, publishing to that specific topic. Okay, great. So we've created the integration. One of the nice things they're helping you is by giving you sample code, created specific for your topics and values. Okay, back to the start. To test it, we'll send the test polls to the Google Cloud, and at the bottom you can see we had success. So we know we can communicate to the Google Cloud. That's not bad from a 150 Rand microcontroller to communicate directly to the Google Cloud. So we've said our end goal is to get data into BigQuery. You'll see in a minute why we skip data flow for now. BigQuery, everyone's heard of BigQuery. It just sounds badass, doesn't it? BigQuery is an enterprise data warehouse. So it's not a database. It's not SQL or MySQL or any of those. So it's not a document store or anything like that. It's a complete enterprise data warehouse. It's used for large-scale data analytics, and it's fully managed. You don't need any DevOps with BigQuery. So we'll start by creating a table. I've been playing around quite a bit. If you're familiar with SQL, it will feel familiar. Just take note of all the little nuances that comes with BigQuery, naming conventions and syntax and stuff. But most of the time, it feels familiar to SQL. You've got all the usual data types to work with. So for the demo, we'll only create a table with 3 fields. And there you go. That was. You don't need to set up indexes. There's very little you have to do apart from you can think about your problem, break down your problem, and use the cloud to support and get advantage from the Google Cloud. Okay, just to test, we'll run a quick query. See, there's auto completion. Okay, and then one little trick is, we'll get to that trick just now. Okay, so we've managed to send data from our device to the Particle Cloud into PubSub, and we've created a table. There's one step left, and that's to set up a data flow. Data flow is, there's not much I can say, it's a data pipeline. That could be, it fetches data from anywhere and it sends it anywhere. And there's a lot you can do around data flow. You can send it to a sheet. You can send it, make an HTTP call with. You can do some processing on your data. There's a lot you can do with the data flow, the Google Cloud data flow. In our case, we want to keep it simple. So we'll use a template that's already been set up to take data from PubSub and send it to BigQuery. Okay, as the moment you select BigQuery, then all the necessary fields open up. And I keep my tabs open so I can go back and cut and paste project names and all those. So in this case we need the table name. And I just noticed now you have to change the naming convention is slightly different when you work with data flow from BigQuery. To keep my talk short, I pre-created the data bucket, and that's all we're looking at here. And there we go, we've got a data flow. We've got a data flow going. A nice visual showing you exactly what's happening. Data coming from PubSub, goes through the job, and it gets written to BigQuery. Okay, for the live demo part of my talk, I will write a BigQuery query to let's just see how my plants are doing today. Okay, let's break this down a bit. Okay, so quickly, what we're trying to do is it's SQL. It's very simple to use. You select your fields. With BigQuery, you've just always got to keep in mind how much data do you query. How big is the data set you query? I don't think we're going to worry too much about my 500 kilobytes, but if your data set is 5 terabytes, I think there's a 10 gig query limit per month on the free tier, and after that you start paying. And if you do a query on a terabyte database, that might cost you 20 Rand per query. So it adds up if you play. But you do get about $300 to play with when you sign up to Google Cloud for the first time. Okay, I'm actually quite nervous to see what's going on here. I have no idea how to resize these things now.
It's another little scroll bar.
It's a little scroll bar.
There's the scroll bar. I can't see it on my screen. Okay, so we started. Let's just go back a couple of a day or so, or to the beginning of the morning.
There's also a handle you can drag that window in the middle, just underneath hide option.
Yeah, but because the screen resolutions are different, I don't have that option yet. So we started off the morning. This was. So we started. Yeah, I didn't get much sleep. That was about 1 o'clock. We started off. I watered the plant. It was at 100, and you can see it slowly. It's slowly reduced. And the latest one we got there. This is UTC time, so that was 27 minutes past 6. Was for 93. I would probably start looking at watering my plants at about 85. They're still good. They should be growing and to become nice and hot chilies.
So your next project is app for your smartwatch.
Has it watered itself yet?
Not yet. Oh wait. Just need to- Okay, my toy chili plant project. It could be your factory with thousands of devices. Did you guys read that? Okay, it could be your factory with thousands of devices. If you can see the Google Cloud Platform giving you value, please come chat to me and we can see how we can take this conversation forward. Thank you.
Thanks, Dries. That was interesting. I just want to know how did it automatically water it? Because I'm useless at remembering to water, even if it's.
For a 20-minute talk, there wasn't enough time to water the plants. If you're happy back late in the year, we can do some analytics on it and actually do some watering.
Cool. Good to hear. Thank you.
Okay.
Thank you so much.
Is there any questions?
Any other questions?
Anybody else? On the creation and publishing of messages using the topics or PubSub, is there a time delay between when you create a topic and when you can actually publish a message?
It's tiny. I've managed to create messages in under a second and keep on sending them. And that limitation was purely just on my side, on the controller side. And I haven't run into a delay yet. So I assume you could be running maybe 100 messages per second.
Cool, because we've got an issue with our current development. We're using Firestore.
Yeah.
If you create a topic, you have a 24-hour delay before you can start sending push notifications and receiving that topic. No. We're talking. Yeah, that's standard.
Yeah, no, with PubSub, you're talking less than seconds. You're talking seconds, or we've got a project where we're sending roughly a few 100,000 messages per hour, and sometimes it's buffered in a way that there's thousands of messages buffered, and it just keeps on sending, and we don't fall behind. It should be able to handle it. PubSub is your entry point to massive, large-scale enterprise systems. I'm speaking under correction, but last year what is that little fluffy game that launched last year, where everybody ran? Pokemon. Pokemon was based on the cloud. Pokemon used the Google Cloud Platform, and it did crash them. They did fall over the first day, and they just added more servers, they added more nodes, and they did some load balancing, and they ended up being able to manage quite well. Yeah.
Any other questions?
In terms of connecting your controller to the Particle Cloud, what configuration did you use? Was it just public?
So what you do with your Particle, it's called the Photon, the Wi-Fi version of the Particle microcontroller I used. It's called a Photon. And the Photon is a Wi-Fi connected device. What you do the first time you use it is you set up your Photon as a web server, and you connect with your PC to the Photon, and then you just reverse all the details get reversed, and it gets all your Wi-Fi information. You set up the username, SSID, and password, etc., and then it's connected.
To the cloud, so to the Particle cloud. So how does that device authenticate?
Okay, so your device is connected to a router. So in my case, I connected it to my Wi-Fi router at home, and through the Wi-Fi router that's connected to the internet and messages. Okay, does that answer your question? Okay. One thing I didn't get time to mention that I just quickly want to mention is to send your data from your Particle Photon all the way to BigQuery. You have to build a JSON object, and the base JSON object has to match the schema of your BigQuery. Sorry, might have made it look a bit simpler than what it is. So you have to make sure that your JSON object matches the BigQuery schema. Okay, cool.
Any other questions? One more.
Where did you buy the Photon in South Africa?
I bought it from an online store. I think it's called Robotics or something. It's about 150 Rand. I can share the link to the...
On the meetup.
Yeah, sure. Okay, I will do that, yeah. Sure.
As well as the sensitive devices.
It's all from the same shop. Okay, so I'll set that up. And what is cool, they've also got a 3G version of the microcontroller with a universal SIM card.
Those don't become sigfox networks, do they?
I'm not sure.
Cool. All right, thank you. Thank you so much, Dries. All right, so we're going to have a quick 15-minute break because there's more pizza, yay, for more free food. But just before we break, I'm going to give away a t-shirt to somebody who can first put up your hand for the answer, but tell me if they can name 3 of the products, the Google products that Dries used in his presentation. Yeah? Congratulations. Cool, yeah, so you can grab some more pizza, hang around for a bit, and then we'll start PJ's talk. Ladies.
We all know. We were like halfway. There's more t-shirts.
I think you've got a special at 150. Now 360. 16 is it?